Hey Cosmic Explorers, welcome back to the channel. In our first journey, we touched upon the sheer scale and wonder of the universe. But have you ever stopped to think, where did it all come from? What was the very beginning? Well, buckle up because today we're diving headfirst into the most widely accepted scientific explanation for the origin of our universe, the incredible, mind-bending Big Bang theory. Now when we say Big Bang, it's easy to picture a giant explosion like a firework, but the reality is a bit more nuanced. Imagine the entire universe, all the matter, all the energy, all of space and even time itself, compressed into an incredibly tiny, unbelievably hot and infinitely dense point. Then about 13.8 billion years ago, this point began to expand. Not into pre-existing space, but rather space itself began to expand. Think of it like the surface of a balloon being inflated. As the balloon gets bigger, the points on its surface move further apart. Similarly, as the universe expanded, galaxies began to move away from each other. It wasn't an explosion in space, but rather an expansion of space itself. And this expansion is still happening today. So, how do scientists know this incredible story is true? Well, there's some pretty compelling evidence. One of the most significant pieces is the cosmic microwave background radiation, or CMB for short. Imagine the early universe just a few 100,000 years after the Big Bang. It was incredibly hot, and filled with a dense fog of protons, neutrons, and electrons. As the universe expanded and cooled, these particles eventually combined to form the first neutral atoms, mostly hydrogen and helium. This event allowed light to travel freely for the first time. The CMB is essentially the afterglow of this early hot universe. It's a faint background radiation that permeates all of space, and it has a very specific pattern of temperature fluctuations that perfectly matches the predictions of the Big Bang theory. It's like finding the faint echo of the universe's birth. Another crucial piece of evidence comes from observing distant galaxies. When scientists analyze the light coming from these galaxies, they notice something fascinating. The light is shifted towards the red end of the spectrum. This is known as redshift. Think of it like the Doppler effect with sound. When an ambulance siren is moving towards you, the sound waves are compressed, making the pitch higher. As it moves away, the sound waves are stretched, making the pitch lower. Light behaves similarly. The redshift of distant galaxies tells us that they are moving away from us. And the farther away a galaxy is, the greater its redshift, meaning it's moving away faster. This consistent expansion of galaxies across the universe strongly supports the idea that everything originated from a single dense point. Finally, the Big Bang theory accurately predicts the observed abundance of light elements in the universe, primarily hydrogen and helium. In the incredibly hot and dense early universe, nuclear fusion occurred, creating these first elements in specific ratios. The fact that we observe these predicted proportions throughout the cosmos is another powerful confirmation of the Big Bang model. It's like finding the exact ingredients of the early universe